Okay, so our course is here in Brightspace, and when you log into the course, you will see the announcements along the right-hand side of the screen. For this first week, we are really looking at sections 2.1 and 2.2 in the e-text, and this is covering the topic of set theory. So I'm going to take a look at these items that are due this week, as well as some important areas of the course. So again, along the right-hand side, these are the announcements. I tried to keep you posted week by week with important items for the course. Down here at the bottom, there's a calendar. And also here at the top, there is our course schedule. I really recommend printing out the course schedule and using it as a checklist for what you're supposed to be working on each week. Pretty much every week we have an assignment in my math lab, and then every other week there is a graded discussion. So you'll see the assignments are denoted with the A's and the discussions are denoted with the D's. If we go back to the course home, there is also in this first tab the Ask a Question board. This is a great place to ask any questions about our homework or how the course operates. Moving on, there's the course information folder with important documents like the syllabus. And now I'll dive right into Module 1 so we can take a look at some of this information regarding sets. So looking here, when we look at sets, there are some PowerPoints available. There's a little bit of notation here. You can see there's set builder notation and things like that. And then you will see some other pieces of notation that will be very helpful. But where I really want to focus is into this first discussion. So for this first discussion, exploring sets, the idea here is that everyone chooses a set based on the first letter of your first name. And people have gone ahead and done that. Now, a couple of things to note. You want to take your set and represent it in two additional ways. And I'm going to use my set here, which was just the integers, -2, -1, 0, 1, and 2. So just those 5 numbers. Okay, so I'm over here on our Blackboard here for the course, and I am going to look at the set. I'm going to call it C for my first name, Kathy, and my set in set roster notation would just be the list of elements in the set -2, -1, 0, 1, and 2. Now, if I were to draw this on a number line, the values in my set are only the dots, they're only the discrete values at those integers and nothing in between. So I don't have anything like 0.5 or 1.7. Those things are not in the sets. It's only these 5 dots. This is what we call a discrete set. Now, I want to contrast this with something like an interval. So some people said, oh, well, maybe we could represent this with an interval, -2 less than or equal to x greater than or equal to 2. This is a closed interval. I can also represent it with the closed brackets. And on a number line, that would look very different. That would look like closed dot on the -2. I'm including the -2. Similarly, I'm including the +2, so I include my endpoints, and I include every value x in between. So this set actually has infinitely many numbers in it. It's got things like 0.5 and 1/7 and -0.9, whereas the set I'm interested in is this discrete set. It's just the dots. So these two things are not equal. All right. So if I'll call this set, I don't know, I'll call it B or something like that. I'll say B equals this closed interval. We can say B, the closed interval, is not equal to C. The closed interval from -2 to 2 is an infinite set with all sorts of values in it, all sorts of real numbers. And that is not equal to just the set of integers, these 5 integers. So If we're looking for other ways to represent this set C, how would I do that? Well, let's see. We could represent C in some other ways. So one way we could represent C would be in set roster notation. We could say curly bracket. We'll have this set of elements X, where X is an integer, and X is between the -2 and 2. That would certainly work when we specify that it's got to be an integer. So that would be a way we could do it. We could get really fancy and we could say, okay, it's the intersection of the closed interval with the set of integers. I mean, I think that's getting really carried away, but it's also correct. You could write it out in words. The picture is also a good representation, but I just wanted to be very clear that these discrete sets are not the same as the intervals. And let's just do one more example so we can see that in action. So I'm going to clear our board here. So let's compare. I'm going to compare. Let's compare the notation 0, 1, the interval from 0, 1 versus the set containing 0 and 1. So over here, this is an interval. It's an open interval, in fact. So I could say it's an open interval. And if I wanted to draw it on the number line, I would say, let's see, here's my 0 and here's my 1. It's the set of values between 0 and 1, not including the endpoints. So I'm going to put an open circle on those ends. If I wanted to express this as an inequality, I could say it's the set of all x's between 0 and 1, not including the endpoints. I could use set builder notation x such that x is a real number. And x is between 0 and 1. But I can't list the items in this set in roster notation because there's so many, there's uncountably many numbers in here. You know, if I started to try and list them like 0.1, 0.01, 0.0001, I would be here for a very long time and then some. So I can't list these elements in set roster notation. So that is very different than what we have over here with the curly brackets. This curly bracket set is a discrete set. The curly brackets, these curly brackets here, an arrow there, this means we have a set, not an interval. We have a set and it has two elements in it. It has a 0 and it has a 1 in it. So if I draw that set, that would just look like the dot at 0 and the dot at 1. And we can list those things. I mean, we only have 2 elements. We can certainly write down 2 elements pretty quickly. So very different ideas with the intervals and the interval notation, and then the curly brackets, the discrete set notation. Okay, I'll pause there. Going back into our course, again, you have all of what you need there in Module 1. The other thing you will need is over here in My Stat Lab. When you click on the e-book, that'll bring up the e-text. And once you get there, you can then click on the Reading for Section 2.1. Now, you don't have to read all of this word for word, but these examples are very good. So here's a word description of the set, and they do that down here. Then they go on to talk about set roster notation, set builder notation, and things like that. Your assignments in my Math Lab can be found under the assignment area. So there's a text and video for section 2.1. So I highly recommend going in here and watching these videos. I won't play the video now, but that's there and that's available for you. And then your homework here consists of questions. Some of them are multiple choice, some of them you would fill in the answer. And at the very bottom of the screen, there are tools like View an Example, and that will bring up a very similar example that you can use as a template. You can also click on Help Me Solve This, and it will prompt you for some additional hints and ideas as you go along solving the problem. Okay? If you have any questions at all, the best place to post those is back in our Bright Space course. Again, posting here in the Ask a Question area.